Hi everyone, welcome to the third and final video for section 7.3, multiplying and simplifying. This is basically just a combination of the first two videos, so we're just merging both of the skills that we've been looking at into one problem. So we're going to head straight into the practice. So what I would like you to do is please make sure that you've attempted these three problems in your guided notes before watching the video. Once you've done that, you can go ahead and check your solutions and therefore add in some extra notes for yourself if you find that they are helpful. So the first thing that I want to note is that in my first problem, I have the same type of root. So this allows me then to write everything underneath one root. The next thing that I note that I want to do is I'm going to start kind of merging things and cleaning them up. So one thing that I could do, I could multiply the 10 and the 15 together, but honestly, since we're going to want to try to simplify this as far as possible, we're probably going to have to do some prime factorization here, which means if I'm going to multiply it and then do prime factorization, I'm going to start breaking it down into its prime factors. So the problem already has it started off for me. Like I already have a 10 and a 15. I can quickly find the prime factors for each of those numbers just fine. And then lastly, I will have that x squared that I'm getting from the x and the x here. Okay, so let's move into those prime factors. So for 10, I know that that's going to be 2 times 5, and I can automatically say that those are the prime factors. 2 and 5 are prime numbers, so I cannot break them down any further. 15 would be 3 and 5, and again, 3 and 5 are also prime numbers, so I don't have to go any further. I can note that I have a pairing of 5 here, so I can kick that 5 outside of the root. But the 2 and the 3, they don't have a partner, so I'm just going to multiply them and put them back in, which is going to put a 6 underneath that root. X squared, again, I have two x's. I have a square root, so that means I can pull one of those x's out, so that one x represents one group of 2. And essentially, I'm done. The next problem is very similar to the one that we previously looked at. The only difference is that we already have numbers hanging outside of the radical. So what I want you to note is inside numbers do not interact with outside numbers. So maybe doing some color coding might help us here. So maybe my outside numbers I'm going to color blue. My inside numbers I'll color purple. And my variables on the inside I'll color green. So if I had variables on the outside, I would use a fourth color. So let's go ahead and start cleaning this up. So outside numbers can be multiplied together to give me 6. And then underneath my square root, I'm just going to write my purple numbers together because, again, I might have to do prime factorization. So then we'll go ahead and we'll write a to the 7th times a to the 3rd next to each other. And what I want you to note is that you can use an exponential rule here. Remember your product rule, your quotient rule, and your power rule. And hopefully you're looking at this one going, oh, this is the product rule. My bases are the same, so what I can do is I can take 7 and 3 and add them together. So I'm going to go ahead and clean that up here and say instead of a to the 7th times a to the 3rd, I'm just going to say that this becomes a to the 10th. So 5 itself is already a prime number. I can't break it down. But 15 I can break down into 3 times 5, which are both prime numbers. Now we can go ahead and see if anyone can escape. So in our first case, I do have one 5 here and a second 5 here. So I can kick we can kick a group out. So this 5 represents a group of 2 5s. Underneath the root, we still have that 3 hanging out, So 3 stays in. The next thing that you want to note, again remembering that your index is a 2, I have 10 a's underneath that square root. So one way that you can approach this problem is to ask yourself, how many groups of 2 can I get from 10 a's? And hopefully we can say, well, I can get 5 groups of 2 evenly. So there won't be any extra a's left over that would have to stay underneath the radical. So we would finish by cleaning this up. So 6 times 5 would give you 30, a to the 5th, square root of 3. This is as far as you can go. For the final problem, we can still use this idea of color coding to help us. So maybe I will color code my a's in red, and I'll color my b's in, or sorry, my b minus c in blue. And notice that they're written in exactly the same order. Both of them are b minus c, and they're also grouped. So that grouping symbol lets me know that I can treat this as one value. Again, we can note that we are working with a 5th root. I have a cubed times a to the 7th times, keeping my colors consistent, b minus c to the 4th times b minus c to the 4th. And let me extend my root out all the way. So I have a couple of product rules that are happening here. So underneath this 5th root, kind of as we previously looked at in our other practice problem, a cubed times a to the 7th, we can use our product rule, and we can have a raised to the 3 plus 7, or a to the 10th. And then for over here, we have b minus c to the 4th times b minus c to the 4th. So the bases match. We can use our product rule to add up our exponents to get b minus c to the 8th. Here is where we can start pulling items out. So as previously noted, I have 10 a's underneath a 5th root. How many groups of 5 can I get from 10? Hopefully we're saying, well, I can pull out 2 groups of 5 a's. Next, it's going to be a little bit different. And actually what I'm going to do to give myself a little bit of space, I'm going to just write that a squared out a little bit further. So note, the next one, I have b minus c raised to the 8th. So that means I have 8 of these b minus c numbers. I can definitely pull out one group of b minus c. So you can just write that as b minus c, or you could write it with a b minus c raised to the 1st power. But after I pull out those 5, how many b minus c's do I have left? And the answer to that would be, I have 3. So remember that the numbers on the outside represent how many groups of 5 you pulled out. The numbers under the radical represent how much you would have left over after you've removed those groupings. So my final answer, the way that I could write this, it's really no different than what I already have, just without color, is going to be a squared times b minus c times the 5th root of b minus c to the 3rd power. This is my final answer. I hope this was helpful. If you have any other questions, please let me know.